Hey guys, in this video I quickly aim to cover some of the questions from the energy section of the 2021 Level 1 Science and Mechanics paper, and I'll just quickly go over it and show you how to do it. So we just get some formulas, and then down here we have the interpreting graph, section speed calculations, pressure, weight, mass, and then here we've got our energy questions. Further down we have work, and then interpreting graphs, and then free body diagrams, and some comparing and some spare stuff and notes. Sorry, extra space. But anyways, the energy questions we can see are right here. So the first question is, when Manaya is 100 meters from the bottom of the cave, her 1 kg torch falls out of her backpack. So she is 100 meters in height and a mass of 1 kg, which is her torch. So it's based around the torch here. So it asks us to calculate the gravitational potential energy that the torch has. Now, in order to answer this, we need to know the formula for gravitational energy, which is actually provided at the top very nicely. So we know that GPE equals the mass times the gravity times the height. Substituting in GPE equals mass, which is 1 times. Now, G is called the acceleration due to gravity, and it has a value of 10 meters per second squared. So basically, if you let go of an object from a height, it will be pulled towards the ground at that, and it will accelerate at that rate each second. So 1 times the acceleration due to gravity multiplied by the height, which is 100 meters, and that gives us the potential energy to be, I think, 1,000 joules. Let's see. Yep, 1,000 joules. Now make sure you don't forget your units for energy. Now this is very important. Next up, it asks us what type of energy does the torch gain as it falls. So in level 1 mechanics, you just need to know the two different types of energy, which is gravitational potential and kinetic energy. So we know that gravitational potential is energy is stored in objects that are held above the ground, and kinetic energy is stored in moving objects. So here we can write that as the torch falls, the gravitational potential energy, so I'll just write GPE, the GPE transforms into kinetic energy. So remember that you don't say that, well, just make sure that you've got an understanding of the conservation of energy, as that states that energy can neither be created nor destroyed. So simply that just means that that gravitational energy will change into kinetic energy. The energies will be equal, the initial states and the final states, assuming the conservation of energy. Now this here is our excellence level question, and it asks us to calculate the maximum speed at which her torch will hit the ground. Now we know that there are only, as this is a question of energy, we know that there are only two equations that describe energy. So that is kinetic energy, which is EK equals half mv squared, and EP, or gravitational potential energy, equals mgh. Now we can see that the kinetic energy one has a velocity in it, so we're going to highlight that. And assuming the conservation of energy, we can say that EK equals EP. Now, since we have already calculated EP, so we're just going to write half mv squared, which is the equation for EK, equals the potential energy, which we calculated as 1,000 equals 1,000. So we're just gonna solve for V, and so rearranging this for V, we get V equals the square root. It's a terrible one. V equals the square root of 1,000 divided by half mass, which is 1, half of 1. I will just put 0.5. And then V equals the square root of 2,000. And then V equals 44.72 meters per second. Now make sure you don't forget units in this problem, as they're asking, as you can see, they're asking about speed, so we know that it's meters per second, and it's not meters per second or meters per second squared, as that is a unit for acceleration, which shows a change in velocity divided by the change in time. So time, the unit for time, which is seconds, appears up twice in that calculation, and basically that means that it'll be meters per second, while when we calculate the speed, it's just meters divided by seconds, distance divided by time, so we get meters per second, and that's the units for speed. Now, there is actually another way to do this problem, and I will show that to you. So let me just quickly get rid of all this stuff, and then I will show that to you. Now, we already stated that EK equals EP, but what if I take that actual equation and make both variables, like both parts, equal to each other? So I would write half mv squared equals the equation for kinetic energy equals the equation for potential energy, so equals mgh. And then we can see that mass is common on both sides, so that can cancel out, so we get v squared over 2 equals gh. Multiply both sides by 2, v squared equals 2gh, and then I'll write up here v equals the positive root of 2 times gravity times height, and then substituting in once again v equals the square root of 2 times 10 times 100 gives us the square root of 2,000, and then v equals 44.72 meters per second. So yeah, that's the energy topic pretty much done from the 2021 mechanics paper, and this final question is an excellence level question. And thank you very much for watching.